In this video, we will go over how to calculate a 90% confidence interval for the difference of two proportions. Let's go ahead and read this problem. It says, during a vehicle crash test, a car manufacturer compares visual damage of two car types in a 10-mile-per-hour crash test. For car type A, 19 out of 100 cars sustained no visual damage, and for car type B, 22 out of 100 sustained no visual damage. What is then the estimated difference in proportion of cars that did not sustain visual damage between these two car types? Let's perform a 90% confidence interval. So again, we want to calculate the 90% CI of P1 minus P2. So this is what we're trying to estimate, or PA minus PB, whichever one we want to use. So remember, that is what we're trying to estimate using our sample proportions. So before we can calculate our confidence interval, we need to make sure that we have random samples or random trials. And here we would assume that we have random trials. It's more of an experiment. So this is met. And we need to have our sample size conditions met. So for a two-sample Z procedure for proportions, this is where our successes and failures for each group are greater than 10. So the number of successes and failures for each group are greater than or equal to 10. In this case, we have 19 successes and 81 failures for the first group. These are both greater than or equal to 10, so we're good there. And for the second group, we have 22 successes and 78 failures, so those are both greater than or equal to 10. So our sample size conditions are met. That's just to make sure that the distribution of differences is normally distributed. So now we can calculate our confidence interval. Well, the confidence interval for two proportions is P hat A minus P hat B, so I'm going to use the subscripts A and B because I have car type A and car type B, plus or minus a Z critical value, it's a Z procedure, times the standard error, which in this case is P hat A, 1 minus P hat A, all divided by the sample size of A plus P hat B, 1 minus P hat B, all over the sample size of car type B. So now all we have to do is just start to plug in values. Well, P hat A is simply equal to the number of successes over the sample size. So this is equal to 0, oh, excuse me, other way around, right? The number of successes over the sample size, which in this case for A is equal to 19 over 100, which is equal to 0.19. And for P hat B, this is equal to 22 over 100, which is equal to 0.22. So we can now plug this into our formulas. We have 0.19 minus 0.22 plus or minus a Z critical value if we're doing a 90% confidence interval. Recall this is 1.645 times the standard error, which in this case is 0.19 times 1 minus that, which I'm going to put in parentheses is just 0.81, all divided by my sample size of 100 plus 0.22 times its complement, which is 0.78, all divided by its sample size. This is then equal to a point estimate value of negative 0.03 plus or minus, again, our critical value of 1.645 because it's a Z procedure, times a standard error. This comes out to be 0.0571. If we scroll down a little bit, get a little bit more room. We have, again, a point estimate of 0.03 plus or minus a then margin of error. So this turns out to be our margin of error of 0.0939. So this will give us a 90% confidence interval from negative 0.1239 to a positive 0.0639. And so when we straddle 0, it's a little bit awkward, the actual conclusion or write-up of a confidence interval, but what it means is essentially there's really no difference between these two proportions. But we'll write up the confidence interval conclusion like this. The 90% CI estimates car type A. So I would just choose one of your car types and then look at the direction in which your confidence interval is going with relation to that, to have a proportion of 0.12 fewer cars sustain damage to 0.06 cars more to sustain damage than car type B. So again, it's a little bit awkward making the conclusion when you have a negative and a positive, but essentially it means that you have fewer cars on one end and more cars on the other when you're straddling that 0.